Welcome to all. Pratibha College of Commerce and Computer Studies Chinswad Pune organizes a certificate course in Basics of Statistics, structured by Department of Statistics. The objective behind structuring this course is to familiarize the beneficiaries with the concept of basics of statistics and the method to measure them manually as well as by using the statistical software like R. After the beneficiaries of this course are all undergraduate students, postgraduate students, researchers, industrialists, as well as government employees. After completion of this course, the beneficiaries are able to understand and calculate the measure of central tendency, measure of dispersions. They are also able to calculate the correlation between two variables, fit the simple linear regression line, and they are all able to perform the calculations of descriptive statistics, correlation, regression in R software. The course is basically containing total 5 modules, from which I, Suruchi Somwanshi, going to conduct module 3 correlation. So let's start with it as it's a correlation test. The content that we are covering in this module are aim for aim uh, of including this module in this course, prior knowledge that is required for this course, learning outcomes, some basic terms, introduction to correlation, types of correlation, correlation versus causation, techniques of measuring correlation, properties, limitations, and its applications. So, the aim of including this module in the course is to familiarize the beneficiaries with the concept of correlation and the method of measure the correlation between the variables. The prior knowledge that the beneficiaries will need to get started with this model is plotting points on the x and y axis, finding the slope between 2 points, finding the equation of a line, linear relationship. At the end of this module, all the beneficiaries are able to use scatter plots to determine the relationship between variables, recognize the range of correlation, match correlation coefficient to appropriate scatter plots, understand that correlation does not imply causality, and calculate the correlation coefficient by using different available methods. Now let's move towards some basic terminology. We start with the very basic term, which is the univariate data. What is meant by univariate data? The term univariate data is bifurcated in uni plus variate form, where uni means one and variate means variable. So, the data having one variable is termed as univariate data. This data consists of observation on only a single variable. For example, salaries of workers, marks of students, travel time in minutes, and puppy weight. Like this data is comes under the univariate data. The another term is the bivariate data. As univariate data is bifurcated in uni plus variate, similarly bivariate data is bifurcated as bi plus variate. Again here the variate means the variable and bi means two. Thus the data consists of variables on observations of variables on two sets is called as bivariate data. For example, height and weight of a person, ice cream sense and temperature, height of father and height of son, like this. With bivariate data, we are interested in comparing two sets of data and finding relationship between them. If we have two variables like x and y, which are giving a set of n pairs, like x1, y1, x2, y2, so on up to xn, yn. This set of n pair is a bivariate data. Again, using this type of data, we are able to compare two sets of observation with each other and are able to find some kind of relationship between them. The another term is scatter plot. So what is meant by scatter plot? Basically, it is a diagrammatic representation used for showing the relationship between two variables. It also measures the direction and strength of a linear relationship. The next term is outliers. Outlier is an observation that lies an abnormal distance from other values in a random sample from a population. In sense, this definition leaves it up to the analyst to decide what will be considered as abnormal. In general, we can say that one or more points from the data or from the observations that do not fit the overall pattern of the observation is called as the outlier. Then there is another term which is a line of based field. A line of based field is a line on a scatter plot which can be drawn near the points to more clearly show the trend between two sets of data. This line is also useful for deciding the direction of the linear relationship. Then the other term is causation. Causation is implying that A and B have a cause and effect relationship with one another. Like if we have two variables and we are saying that one variable is causing the another one, or it is the reason behind the happening of the another one, then there is a cause and effect relationship between the two variables, and we can say that A causes B. Causation is also known as causality. Firstly, causation means two events appear at the same time or one after the other. And secondly, it means these two variables not only appear together, the existence of one causes the other to manifest. Let's now move towards the correlation. So what is correlation? Basically, when two things go together, we can able to determine some kind of relationship between them, like cookies and milk, macaroni and cheese, peanut butter and jelly, like this. So more often or many of the times we come across situations where two variables are interrelated with each other and we may want to investigate the relationship between them. What kind of relation they have having or they possessing with each other, that thing we want to investigate. One variable having some kind of relationship with another one. Like we have one variable which is showing that he has that particular variable is having some kind of relationship with another one. Like on the basis of our monthly income, we can decide what would be our monthly expenditure. So the correlation is nothing but a statistic that measures the degree to which two variables move in a relation to each other. It also tells us how strongly the pair of variables are linearly related and change together. But ultimately, it is not going to tell us why and how this relationship is exist and what is behind the relationship. But it just says that the relationship is exist. If we consider an example like the capacity of engine and the fuel efficiency of an engine, or the sale of ice cream and the temperature, the number of hours studied by a student and their subsequent performances in an exam. So ultimately, the correlation analysis means examining such relationship systematically. The correlation coefficient is a mathematical way of measuring the linear relationship between the variables. If we want to find some numeric value between the for the relationship between the two variables, then it is called as the correlation coefficient, or we measure that numerical value by using the correlation coefficient. Thus, it is called as a mathematical way of measuring the linear relationship between the variables. When correlation studies and measure the direction and intensity of the relationship among the variables, how strongly the two variables are related with each other can be determined by using the correlation. Also, it's mentioned the direction of their relationship. Again, the presence of correlation between two variables, say x and y, simply means that when the value of one variable is found to change in one direction, the value of the other variable is found to change in either in the same direction or in the different direction or opposite direction. So if it is changing in the same direction, then the change is positive change, and if it is changing in opposite direction, then the change is negative change. So this is how we measure the direction by using the correlation. Then what type of question the correlation deals with? So particularly if you need answer for is there any relationship between two variables, or for if the value of one variable changes, does the value of the other also change? Do both the variables move in the same direction? How strong is the relationship? So like these type of questions can be answered by using the correlation. So if you need to answer something like this, you are able to use the correlation. And there are different types of correlation. So mainly we can uh, bifurcate the correlation in three types, or we divide the correlation in three types. The one is positive correlation, the another one is negative correlation, and the third one is no correlation. Now we are going to discuss these types of correlation one by one. So we may somehow face the situation where we see the example like this. The faster a jet pilot flies, the higher the G forces are. Here we are observing that we have two variables, that is the speed of the uh, um, jet, or the speed of the jet, and the G forces. So here, as the speed of jet pilot is of the jet pilot flying is increases, the G forces are also going to be increases. So the faster a jet pilot flies, the higher the G forces are. That means both the variables here are increasing or moving or changing in the same direction. Okay, so this type of relation is termed as a positive correlation. Means the correlation is said to be positive when the variables move together in the same direction. For example, when the income rises, consumption also rises. When income falls, consumption also falls. Again, sale of ice cream is increasing as the temperature increases. The next situation is that we saw some examples like this. The older a man gets, the less hair that he has. That means here the two variables which we have, the one is the age of the man and other one is the count of the hair. As age is increasing, the count of hair is decreasing. Means once the one variable is increasing here and other is decreasing here. That means both the variables are moving simultaneously but in a different direction or a opposite direction. So this situation leads us to the negative correlation. So what is negative correlation? The correlation is said to be negative when the variables move in the opposite direction. For example, when the prices of apples falls, its demand increases. When the prices rise, its demand decreases. Or if car decreases its speed, then the travel time to reach the destination will increase. So like this, here both the variables are changing simultaneously but in a opposite direction. Like if one is increasing, then another one is decreasing. Or if one is decreasing, then another one is increasing. So if we face situation like this, then the relationship between the variable will be the negative relation. Then, if we have a relation between the amount of tea drunk and the level of intelligence. So basically, anything or the intelligence is not at all based on the tea drum, the amount of tea drum. That means how much amount of tea you are drinking in a day is not at all affecting the level of IQ, your level of IQ. So this type of relation is no correlation or a zero correlation. So sometimes change in one variable not at all affecting the change in the other variable. Then we say that there is no correlation or variables are uncorrelated. For example, the prices of coffee and prices of computer. The prices of coffee not at all affecting the prices of computers. Similarly, height of students and level of IQ. Price of milk and price of pens. The prices of milk rises or increases or decreases does not at all affect the prices of pens. So these type of relations are no correlation or a zero correlation. That means these variables are uncorrelated. After this, let's look what is the relationship between the correlation and causation. So what is correlation and what is causation that we have just studied? Now we have to check the relationship between them. So let's see here one picture I have given to you. Here the lady is reading out the newspaper and she found one news in the newspaper which is saying that a new study found Colorado has the lowest obesity level of any state. And she is thinking that you know what that means? Forget dieting, we are moving to Colorado. So that means she is thinking that they are living on a wrong state or a wrong place. If they move to the Colorado, but obvious she is going to lose her weight. But this study found that Colorado has the lowest obesity level of any state. That doesn't mean if you live in a Colorado will be going to affect on your obesity level. That doesn't mean here. Okay, so this is the uh, relationship in correlation and causation. So here let's take a deeper view towards this. So correlation and causation are terms which are mostly misunderstood and often used interchangeably. Understanding both the statistical terms is very important, not only to make the conclusions, but more importantly, making correct conclusions at the end. Like the lady is concluding that we are moving to Colorado so that she will lose her weight. Okay, so to make a proper conclusion, we need to get proper understanding about the terms correlation and causation. So if we take a step further than the correlation, then it says any change in the value of one variable will cause a change in the value of another variable, which means one variable makes other two happen. It is also referred to as the cause and effect. Okay, so if you move to the Colorado, that does not going to cause the or that does not be the reason for your low level of obesity or losing the weight. That is not going to cause your losing weight. Okay, so there is no cause and effect relationship between the moving to Colorado and the obesity level. Okay, so there is a relationship between the person who is living in Colorado and his obesity level, but the two variables are not showing the cause and effect relationship. Okay? So here, a lot of times we have heard correlation does not cause causation, or correlation does not imply causation, or correlation is not causation. But what they mean actually by saying this? So why correlation does not imply causation? Okay. So like the above example we have discussed. moving to the Colorado is not going to affect on the obesity level. Okay, study found that the persons who are living in Colorado have a low level of obesity. But if you thinking that if you move to the Colorado, then it will cause the low level of obesity in you, then that is not the correct interpretation. So here causation correlation is not imply the causation. There is a correlation between the persons living in Colorado and having a low level of obesity, but it is not implying that if you move to the Colorado, then it will cause the low level of obesity in you. Okay, so that's why correlation does not imply causation. When we uh, see this with some more example. So when a person is exercising, then the amount of calories burning goes up every minute. Former is causing latter to happen. So here, when you perform the exercise, your calories will going to burn. So exercising causing the burning calories. So here the cause and effect relationship exists. So now we know what correlation and causation is. So it's time to understand correlation does not imply causation with a famous example. So what is that example? Ice cream sales is correlated with homicides in New York. See, it is a study that ice cream sales is correlated with homicides in New York. So as the sales of ice cream rise and fall, so do the number of homicides. So does the consumption of ice cream causing the death of the people? Is it possible that if you consume the more ice cream or if you consume the ice cream then you will going to be die? So no. Two things are correlated doesn't mean one going to cause the another one. So correlation does not mean causality. Or in our example, or particularly in this example, ice cream is not going to cause the death of the people. Again, I'm going to give you one more example for this. So see, ice cream and sunburns have some kind of correlation between them. Okay, ice cream and sunburns have some kind of correlation between them. But that doesn't mean eating an ice cream will cause the sunburns. Okay, but there is a correlation exists in between these two variables. Okay, ice cream and sunburn. So how the correlation is reflecting here, as it is not uh, logically there is no relation between these two, but still we are seeing some kind of relation between them. So how it is happening? It is happening because of some third party or some third variable, which is here dry, hot, and sunny summer weather. So this sunny summer weather, causing the uh, ice cream capacity of eating ice cream or causing the more sale of ice cream. Okay, because it is hot outside, so I need something that cools my body, so I'm eating ice cream, and as it is hot outside, it causes sunburn to me also. Okay, so hot sunny summer weather is causing sunburns also, as well as it is increasing the sale of ice cream also. So that's why we are seeing the correlation between the sunburn and ice cream because of this weather. So sunburns and ice cream, summer weather and ice cream, summer weather and sunburns, they will have a cause and effect relationship. But ice cream and sunburns, the relationship between these is not the cause and effect relationship. So correlation does not imply causality. Again, it seems a little bit difficult to understand, correct? So let's take one more example. See here, the person is saying that he is honestly don't have any idea why he is getting a weight gain, why he is having a gain in his weight. See here, he is eating a lots of junk food. He's eating a lots of junk food that is causing his gain in weight. So what is the cause here? The junk food. And what is the effect of that? It is a weight gain. Okay? So this is the cause and effect relationship. One another example is there. If the students missing the most classes get lower grades. The suggestion is that there is a causal relationship between the attendance and the overall performance. So this is the relationship between the correlation and the causation. So correlation does not imply causation. Now let's move towards how we are going to measure the correlation. So basically, there are two techniques of measuring the correlation: scatter diagram and the Karl-Pearson's coefficient of correlation. So let's see them one by one. So the first one is scatter diagram. So what is scatter diagram? It is a diagrammatic representation technique for showing the relationship between two variables. It is useful technique for visually examining the form of the relationship between two variables. Particularly in this technique, the values of the two variables are plotted as points on a graph paper. In a scattered diagram, the degree of closeness of the scatter points and their overall direction enable us to examine the relationship. So, the scattered diagram, in the scattered diagram, if all the points lie on a line, the correlation is perfect. If the scatter points are widely dispersed around the line, then the correlation is low. The correlation is said to be linear if the scatter points lie near a line or on a line. So these interpretations or these things we are going to see by in the proper diagrams or in a proper scatter plot diagram. Okay, see, if we are discussing about the linear correlation, then these types of scatter plots we can get for various types of data. Okay, so these scatter plots which are in our left side, okay, that are the linear relationship, that are showing the linear relationship. If we have a linear relationship between two variables, then the scatter plots will look like these two plots. And if we are having a curvilinear relationship between the two variables, then the scatter plots are going to look like this. Then again, there are another type of scatter plots. If we have this type of scatter plots, then again the left hand side scatter plots are showing the strong relationships. Okay, strong relationships are there. The first scatter plot on the left side showing the positive strong relationship, and the second one is showing the negative strong relationship. Again, the right hand side scatter plot is showing the weak relationship. Okay, in the left hand side scatter plot, the points are very dense. Okay, that's why it is showing the strong relationship. The points are dense towards the line of the towards the center line. Okay, that's why it is a strong relationship. And that in the right hand side scatter diagram, the points are dispersed, widely spread from the line, center line. That's why there is a weak relationship. Again, there is one more type of scatter plot which we can find out while studying correlation, which is look like this. In this type of scatter plot, we say there is a no relationship between the variables. If this type of scatter plot we found or we see, then the variables are uncorrelated. Now, let's see one example for scatter diagram. So here one example where we have to draw a scatter diagram for the given data, where the X is representing years of education and Y is representing the age of entry into the labor force. We have some data for this. We have X values like 10, 12, 15, 8, 20 like these, and we have Y values like 16, 17, 18, 15, 18, 22 like these. So we want to draw a scatter diagram for this. So we are going to just plot an XY plane On x-axis we are going to take year of education, and on y-axis we are going to take age of entry into the labor forces, and we are just going to plot all these points, xy points, on that xy plane. So the scatter diagram will look like this. Okay? So from this scatter diagram we can interpret that there is a positive correlation between the variable x and y. How we are saying that there is a positive correlation? See, the direction of the points is from down left side to upward to the right side. Correct? So this is the direction of positive correlation. That means one variable is increasing, so the another one is also increasing. Okay, that's why we are saying that here is the positive correlation between x and y. Now, see, these figures will help you to interpret the scatter plot more precisely. Okay, so if you have a no correlation, then the scatter diagram will look like this. The points are more dispersed or more scattered in the xy plane. If you have a no positive correlation, then the points direction, the scatter plots, after plotting the points on a scatter plot, the direction will going to be left downside to right upside. Okay, left downside corner to the right upside corner. Okay, so if this type of direction you see, then there is a positive correlation. Now we have to decide it is a low, high, or a perfect. So if the points are scattered very much, then it is a low positive correlation. If they are dense to a center line, then they are high positive correlation. And if all the points are plot on a single line, then they are a perfect positive correlation. Similarly, negative correlation is there. So the direction of the negative correlation is, if you plot the points of the scatter plot on the xy plane, then the direction of the points will be look like this, like upper left corner to the down right corner. So this direction shows the negative correlation. Now again the question is, what is the low, high, and perfect negative correlation? So similar, as same as the positive correlation, if the points are very much scattered on the xy plane, then the correlation is low negative correlation. If the points are very much dense, then it is a high negative correlation. And they are perfectly on a same line of base fit, then it is a perfect negative correlation. So it will help you to interpret the scatter plot. Now, there is another method for calculating the correlation coefficient, which is Karl-Pearson's correlation coefficient. So as we have a scatter diagram for measuring the relationship between the two variables, then what is the need of defining the Karl-Pearson's correlation of coefficient? So basically, scatter diagram just provide us a diagrammatic representation. It states us that is there any relationship between the variable or not. Is it a strong relationship, weak relationship? It also can be determined by using the scatter plot. But how much the relationship, numerically, how much is the relationship between the two variables cannot be defined or stated by scatter diagram. So for that, we use Karl-Pearson's correlation of coefficient to find out some numeric value for the relationship between the two variables. So we use Karl-Pearson's correlation of coefficient. This particular correlation coefficient was determined or derived by Karl Pearson. Okay. So to go to the Karl-Pearson correlation coefficient, firstly we need to know about the covariance. So what is covariance? The covariance is the joint mutual variation between two variables. The covariance between x and y is denoted by covariance of COV of xy, which is read as covariance of xy, and is defined as covariance of xy is equals to summation of x minus x bar into y minus y bar upon n. After simplifying, the formula will be covariance of xy is equals to summation xy upon n minus x bar into y bar. So this is how we calculate the covariance, which is nothing but the joint mutual variation between two variables. Now, what is the Karl-Pearson coefficient of correlation. Now, how we are going to calculate it? So, this coefficient of correlation is also known as the product moment correlation coefficient or a simple correlation coefficient. It gives a precise numerical value of the degree of linear relationship between two variables x and y. The correlation coefficient given by Karl Pearson is denoted by R and it is defined as follows. So R is equals to covariance of xy divided by under root of variance of x into variance of y. So that is R is equals to covariance of xy upon sigma x sigma y, which is standard deviation of x and standard deviation of y. That is where sigma x is under root of variance of x, which is standard deviation of x, and sigma y is equals to under root of variance of y, which is standard deviation of y. So this is the formula which we use to calculate the correlation coefficient derived by Karl Pearson. How we are going to interpret the value of R, the correlation coefficient. So if we get the value of R greater than 0, then there is a positive correlation between the variable. If we get R less than 0, then we can say that there is a negative correlation between the two variables. If we get R equals to 0, then we can say that the two variables are uncorrelated. If we get R equals to 1, exact equals to 1, then there is a perfect positive correlation between the two variables. And if we get R equals to minus 1, then there is a perfect negative correlation between the two variables. So this interpretation we have to remember for concluding our value of R or the correlations between the two variables by using Karl Pearson. So let's see how we are going to calculate the correlation using this formula given by Karl Pearson. Let's consider one example where we want to calculate the correlation coefficient for the given data. The data is given for the x and y values, where x values are 12, 15, 18, 21, 27, 25, and 28, and y values are 2, 4, 6, 8, 12, 9, and 15. So, in between these two variables, we want to calculate the correlation. So, we can say that we want to check is there any type of correlation between these two variables or not. If yes, then what kind of correlation is that? So, let's see how we are going to calculate. So, we have see the formula for correlation coefficient R is covariance of xy upon sigma x into sigma y. So to calculate the covariance of xy, sigma x and sigma y, we need some primary calculations. Okay, what are they? We need the values of x square, we need the values of y square, and we need the values of x into y. So we calculate these all values. Okay, so x and y we need to square the values of x. That is x square we will get. So square of 12 square is 144, 15 square is 225 like this. Here y square we are getting by squaring the y observations. So 2 square is 4, 4 square is 16, 6 square is 36 like this. Then we need to calculate x into y, which is 12 into 2, 24, 15 into 4, 60, 18 into 6, 108 like this. And ultimately we need sum of all these columns. So we take the sum of all these observations of these columns. Okay, so we will get sum of x as 146, summation of y as 56, summation of x square as 3272, summation of y square as 570, and summation of xy as 1329. Now let's move for calculating the sigma x, sigma y covariance of xy value and ultimately the Karl Pearson's correlation of coefficient. So firstly we calculate the x bar and y bar values. Okay, mean of x and mean of y. So it is calculated as summation of x upon n, which is equals to 146 upon 7, where 7 is the total number of observation in our data set. Summation of x that we have just calculated in the above table, which is 146. After simplifying this, we will get 20.8571. Similarly, if we calculate y bar, which is mean of y, the formula is summation y upon n, which is equals to 56 by 7, which is 8. 56 is again the summation of y, which is calculated in above table. Then we will calculate sigma x, that is standard deviation of x. The formula is under root of 1 upon n summation xi square minus x bar square. So the value of n is 7 here, so 1 upon 7 into summation of x square. Summation of x square is 3 to 7 minus x bar square. So x bar we just calculated, which is 20.8571. So we have to square that value. And taking the square root of this equation, we will get 5.6928, which is nothing but the standard deviation of x. Similarly, we have to calculate standard deviation of y. So the formula is under root of 1 upon n summation yi square minus y bar square, which is equals to under root of 570 upon 7 minus 8 square, which is equals to 4.1748. After calculating the standard deviation of x and y, we have to calculate the covariance of xy. The covariance of xy is calculated by using the formula summation of x into y upon n minus x bar into y bar. So the summation of x into y is 1329, which is calculated in the above table, divided by 7, which is total number of observations in the data set, minus x bar into y bar, which is 20.8571 into 8. If we calculate these, we will get 23. The covariance of xy is 23, sigma y is 4.1748, and sigma x is 5.6928. Now we just have to put all these values in the formula of correlation coefficient given by Karl Pearson. So Karl Pearson's correlation coefficient is R is equals to covariance of xy upon sigma x into sigma y, which is equals to 23 upon 5.6928 into 4.1748, which is equals to 0.9678. So with the help of this value, we can interpret that the correlation coefficient R is equals to 0.9678. That means the variables x and y are highly positively correlated. Okay. If this value comes minus 0.9678, then we can say that the variables x and y are highly negatively correlated. The positive and negative can be determined by using the sign of the value that is calculated for R. If R is positive value, then the correlation is positive. If R is equals to some negative value, then the correlation is negative. Like this, we can interpret the value of R. So this is how we calculate the correlation coefficient by using Karl Pearson's correlation coefficient formula. Now, after this, let's see some properties of correlation coefficient. So, the very first property of correlation coefficient is that R has no unit. It is a unitless quantity. It is a pure number. Again, second property is that the correlation coefficient lies between minus 1 and 1. That means minus 1 is less or equals to R less or equals to plus 1. That means the value of R is not going to exceed minus 1 and plus 1. It will always lie within this range. It will take exact minus 1, it will take exact plus 1, but not going to exceed these two values. The third property says that correlation coefficient is not affected by change of origin. In other words, if a constant is added or subtracted from each observation, correlation coefficient remains same. That is, there is no effect of change of origin on correlation coefficient. That means correlation of x plus minus a, y plus minus b is equals to correlation of xy. The another property is that the correlation coefficient remains numerically same under the change of scale. In other words, if we divide or multiply each observation by some constant, some same constant, then the correlation coefficient remains numerically same. That is, correlation of ax by will be correlation of xy if a and b both have same algebraic sign, and it will be equals to minus correlation of xy if a and b have opposite algebraic sign. Okay. The another property is that correlation xy is equals to correlation of yx. The relation that variable x and y will showing, the exact relation will y and x will show. Okay, that's why correlation between x and y is equals to correlation between y and x. Then correlation between x minus y is minus correlation of xy. Correlation of minus xy is minus correlation of xy. So these are some properties of correlation coefficient. Now let's move towards the limitation of correlation. What are the limitations of correlation? So we are only considering the linear relationship here. We are not considering any other kind of relationship. We are only focusing on the linear relationship. Then R is affected, highly affected by outliers. If some kind of values are far away from the actual pattern of the or not fitting in the actual pattern of the observations, then the value of R, which is correlation coefficient, is highly affected. There may be variable other than X which are not studied yet do influence the response variable. In general or logically, we cannot see the relationship between the two variables, but there is one third variable which is having some kind of relation with both these two relationship between them. A strong correlation does not imply cause and effect relationship, and extrapolation is dangerous. So these are the limitations of correlation. Let's see